चल गया.
Okay, so can you calculate K1, K2 and K3? Then you have to calculate the yield strength B by 1. So 3 modes are given. Yesterday we discussed 3 modes. Strength in the 3 modes is given. You can calculate. Okay, so the expected compressive strength is given. Okay, then the shear diagonal tension strength is given, which will control the diagonal shear. Okay, and sliding shear is also given. So you will calculate the strength in the 3 modes. Okay, and you will determine in which mode it is failing. So for example, if you have to calculate the strength in, let us say, rocking, how you will calculate? Yesterday we discussed in rocking it will okay, and there will be a force being applied from the top. So how much will be the rocking strength? You can calculate either from equilibrium or from crushing of the toe here. Okay, so when this toe will crush, then it will fail, or when it overturns. So for this you need to calculate this vertical load P. Okay, and you have already done PM instruction for a masonry, not like this, but like this if you are ignoring it. Okay, so you can calculate for a given P what is the value of M. Can you do that? In the first tutorial we have plotted PM interaction curve for masonry. At any given force P, we can calculate the yield strength. How? The stress strain curve at any section. This is the stress strain curve. The stress strain curve of masonry and concrete. We assume to be similar. This strength is given. Okay, you can calculate this force and then you can calculate moment about the center line, not at the neutral axis but about the center. This will give you M1, and from M by you can calculate B by. What is B by? Simply M by divided by H, and here it will be bending in double curvature, so it will be H by 2. Yes.
We are considering this stress diagram similar to concrete.
Right.
So the stress equation we are using is concrete. Same will be
Same will be.
So 0.002 strain we are using in concrete.
So either you can calculate M by dash first, and then from there you can get M by. Okay. That M 0.004 is not strictly valid here. Okay, because that is in case of RCC. So that is not valid in case of masonry. So for M by dash, the strain you will assume, the maximum strain, compressive strain, you can assume this is equal to 0.001. Okay, so you will get the stress diagram. This C you have to calculate, and this C you have to equate to the vertical load P. because there is no tension force in case of masonry. That will give you this depth of neutral axis. Okay.
I am asking sir that for that curve, stress curve, I need to, we have using equation for RCC as 2 times of epsilon upon.
Same will be used here. We are assuming that the stress strain curve for concrete and masonry is same.
No, so there is 0.002. Here maximum is 0.0015. So that 0.002 also reduce. What is that value?
You have done this in case of concrete also. When the concrete fiber was yielding, the strain you have taken 0.0015. And at that case you have calculated C in concrete. How did you calculate? You have integrated it up to 0.0015. Same thing you will do here.
But sir, I am saying that strain that where the yielding completes, that is in concrete 0.002. In masonry it will be same.
If stress strain curve we have assumed to be same, then it will be same. We have assumed that the stress strain curve of concrete and masonry is same. Okay. If you are interested in knowing the exact stress strain curve, you can look into strain code. Okay, but here for the purpose of calculation, we will assume that the stress strain curve of concrete and masonry is same. So everything will be same. Constitutive law is a stress strain curve. That itself we have assumed to be the same. Only thing is that the strength here, this strength which we are getting, rather not here, but here, this you will use Fm dash. Okay, so what is Fm dash? Fm dash is the strength in masonry. Okay, this is obtained from prism. Okay, so same will be used. No 0.8 or 0.85 factor shall be used. Okay, whatever is given in the question, that same will be used here. In case of masonry, how we get the compressive strength? We test a prism, not a cube or cylinder. We test a prism. Okay, and the height of the prism is sufficiently large so that the end friction effect is not there. So we need not to do any correction for end friction effect. We need not to do any correction for the size effect. So whatever is given there, that you will do.
So 0.0015 is the maximum strain of masonry compression.
Yes, when we are assuming it to yield in compression. The first yield in compression, we will assume when this strain reaches 0.001.
Why we are taking up to yield? Why we are taking up to yield?
Because we want to calculate m by dash.
But I am talking about failure mode, so my failure will occur at.
Okay, but we have to plot the Q versus delta curve. So Q versus delta curve, you need this Qy, isn't it? And corresponding delta y. This is K1 which you have obtained. Then Qy you will get from there, then Qy divided by K1 will give you delta y. Okay, and this you can calculate Qu and the corresponding delta u. How you will get delta u? Ductility is already given. Ductility ratio. Okay, so ratio of delta u by delta y is given in the question. That will give you delta u. How you will get Qu? Taking ultimate strain in place of yield strain. And Qy will be Qy dash over 0.7. We will use approximately same. Okay, so can you do it for all the 3 tiers? Calculation for shear is very easy, and this will be, this Qy will be minimum of Q rocking, Qy rocking, Qy diagonal shear and Qy slide. It will be minimum of the 3 because whichever strength is minimum, it will fail in that.
So if we assume the strain of masonry and concrete, then we have considered compressive force. that is when in tension, we have
There is no tension. There is nothing to take tension. Masonry cannot take tension and there is no reinforcement. So can it take moment?
no, that's
This you should not say after doing rule number 1. You have plotted PM inflection curve.
yes sir, not in tension.
So PM inflection curve for masonry also you have plotted this.
Yes.
So it can take moment. With axial load it can take moment. So what you need to know is the axial load. How you are going to get the axial load?
Weight from the top.
Hmm?
Weight from the top.
Weight coming from the top, you have to perform analysis for vertical load. So there is a slab at the top. That slab load you will distribute in inline pattern. That will give you the load coming from the slab at the top. Then on this pier, you will see that this pier load will also come. How you will distribute? Let's assume that load, let's replace by equivalent UDL. The total load I will divide by total length. So how you get force here, actual force here in this pier?
Reaction of these. Reactions of these.
How you will obtain reactions? You just take this tributary length, center of opening, or let me use a different color. So this load will go here, this load will go here, and this load will go on this in symmetry. Okay? From this span, half will go this side, half will go this side. Approximately. This is for top story. What will happen to the ground story? Whatever force is here, that you calculate, then into that add slab and plate. So whatever is coming from the top wall, that will be transmitted. In addition to that, slab and the top pier, top wall segment. That will give you the axial force. With that axial force, you can calculate the moment capacity m by dash, as I explained to you. From m by dash you will get m by, then you can calculate qy in flexion. Okay, qy in sliding shear, how you will calculate qys? Sliding shear strength.
I will calculate shear stress first,
Mhm.
and if there is
Can
shear
you tell me?
stress, that formula is required.
Yes, in this question, shear strength is given. So how you will calculate?
If it exceeds this much, if it exceeds this,
No, I am just asking you to calculate, not exceeding or anything. I am just asking you how to calculate QIS. What would be the formula for QIS? It's simple. T into L into the sliding shear strength. The cross-sectional area. What will be the diagonal? Shear strength T of that pier into L of that pier into tau D, the strength. That will be your periphery. We are calculating for one pier, not for periphery. For this wall, there are 3 piers. So we will calculate Q1 YS for this, Q2 YS for this, and Q3 YS for this. minimum of these three QY, that will give us the yield strength QY here. And then you can calculate QU you will calculate for the same mode for which the yielding is occurring. So you have seen that in case of rocking, it is increasing. What will happen in case of QYS and QYD? It will remain constant. So if this failure is occurring in rocking, then you will get a strain hardening. Okay, you will calculate QU corresponding to a strain of 0.0035. Okay, if it is yielding in diagonal shear or sliding shear, this will remain flat. QY and QU will remain same.
In diagonal tension, the area should be along the diagonal.
Diagonal shear is also represented in terms of cross-sectional area, not along the diagonal. Tension is occurring along
Diagonal
diagonal.
tension is given.
Yes, diagonal tensile strength is also given in terms of cross-sectional area.
Sir, but this the capacity which I will get by diagonal, this will be less now. My diagonal length will be more if I consider.
No, that's what I am explaining. That this is tau. The failure will occur along the diagonal, but tau d is measured along the cross section. It is not measured like this.
Sir, action is along, means reaction is getting from diagonal element, action is along this surface sliding. So action and reaction must be in one plane. जहाँ से reaction
Action is
आप फोर्स जो अप्लाई कर रहे हो वो
I am applying force here.
हाँ and
Here.
and reaction.
So I will measure the force which I am applying.
Yes, that will be demand on that pier.
Right.
But reaction is getting from diagonal.
No, reaction is coming here, not from diagonal. Failure is occurring along diagonal, but reaction will be here. If I am applying a force in horizontal direction, what will be the reaction? Horizontal.
Horizontal.
Reaction cannot be diagonal. Until unless I apply a vertical load also. And if I apply a vertical load also here, sorry, then from here also I will get vertical load. So failure is occurring along diagonal. That doesn't mean that we are measuring the force also along the diagonal. The force is measured along the horizontal cross section only. In both the cases, whether it is sliding shear or it is diagonal shear. In sliding shear, the failure will occur along this, but still the shear is measured on the cross section. Okay. Any doubt? So can you now complete question number 1?
Sir, that slab will you are wrong pattern that will distribute according to tributary area or
You mean vertical load. It will be distributed according to tributary area. This will be distributed according to tributary area. So first of all, the floor load will be distributed according to its tributary area to the four walls. Then when it will come on the wall, it will be distributed to different piers in proportion to the tributary length of different piers. Right. Slide. So what I mean is what you have already done in case of frame, that in one case the force will be acting here only. This is one. In the other case, it will be Q here and 2Q. Linearly varying means that actually it will be varying along the length of the wall also, height of the wall also, sorry. But we assume the earthquake force to be lumped at the floor only, so that our calculation is easy. Otherwise our calculation will be bit complex. Okay? Okay, yes. Okay. What are spandrels? These which you are having, or let me go. This is already congested full. So these vertical members, these are called piers. These are piers. P1, P2, P3. And horizontal members, you can see this acts like a beam. So spandrel is nothing. We have talked about spandrels earlier also in coupled here. Okay. So what is a spandrel? Spandrel is a deep beam. So these portions will act as deep beams. These are called spandrels. So these spandrels you can assume to be rigid. Okay. So that's why we have just calculated the load displacement curve of these three piers and we have added those. In reality, what will happen? These piers, these spandrels will also deform and it will act like a frame. Okay. So another modeling of this wall can be an equivalent frame. And how it will look like an equivalent frame? The first pier will have this length, second pier will have this length, and the third pier will have this length. So you can also model this as an equivalent frame. So one type of modeling of shear wall, masonry walls is equivalent frame. The other type of modeling is pier model. So what we are doing here is pier model. In pier model we are assuming that spandrels are rigid. So we are not considering the deformation of spandrels. What will happen here? Here the spandrels will also deform. The spandrels will also bend in the frame. That you may learn in your masonry. I don't know how much he is covering, but the equivalent frame model you may. If some of you are interested in doing equivalent frame model, you can perhaps do dissertation on modeling of masonry walls using equivalent frame. So equivalent frame model is also used for modeling masonry walls. Here we will be using a simpler method, and that is this pier method, where spandrels we are assuming to be rigid and all the deformations we are assuming to occur in piers, which is quite reasonable because you have seen that this thickness is quite large and not much deformation is happening. Okay. Any other question? So please do this, because if you are not doing it in the exam, it will not be possible to do without practice. Let's look at question number 2 now. We have done this already yesterday, but just have a look. If you have any doubt, anything you want to ask. So here the factor moment capacity is given. What is meant by factor moment capacity? Design moment. Okay, factor design moment, for which we have designed over here. Then overstrength factor is also given. Overstrength factor of 2. What does that mean? That the yield moment capacity is 2 times of the design capacity. Yesterday I told you. So the yield moment capacity of all the piers is same as 20,000 kilometer meters, and then ductility ratio of 5. And when we say ductility ratio, it is rotational ductility, not the displacement ductility. Rotational ductility. So rotational ductility is given 5. Can you plot load versus displacement curve? That is the capacity curve. No, those are continuous. But at the top of the pier there is a pin. So here our superstructure is continuous, but it is connected to the piers through a pin. Like this. So it is connected to a pin. Not load. All the three supports are pin support. Superstructure is continuous. Okay. And the piers at the base you can assume to be fixed. In reality, piers will not be fixed at the base because it will be having some foundation, and that foundation can deform. So some rotation can happen. But here you can assume it to be fixed. Okay, I don't think there is any issue in this. Any problem? Yes, we can solve that. Let's go to question number 3.
So since there is a hinge condition, so plastic will not form in the superstructure.
Plastic hinge will not form in the superstructure. Plastic hinge will also not form at the top of the thing.
Yes, because already
The deformed shape is going to be like this. Deformed shape is going to be like this. This displacement will be same. Question number 3 is very similar to what you have done in tutorial number 2. Okay. Only thing is that the numerical value of beam capacity is given.
We have actually framed 3 in parallel.
Yes, and the 3 frames will act in parallel. So whatever capacity curve you will obtain for one frame, that will be simply multiplied by Q, and Q will be multiplied by 3, not the delta. So at any given delta, the Q will be 3 times. And in question number 4, there is a correction. It is not Q2, it is Q3. So in Q3, if there is a gravity load of 15 kN per meter square also acting, then due to P delta effects, what will happen? So you know that. So any problem you feel up to question number 4?
Gravity load we have added.
Gravity load we have added.
Story 1, story 2, and story 3, bottom, story 9,
When we will calculate or when we will calculate? 15 kN per meter square for one floor. 1 floor. 15 15 kilonewton per meter square of floor area. Okay.
Then we have 4 pieces empty when we have calculated. Then
When you will calculate for the ground story, you will consider the gravity load of the 5 stories also. Because the gravity load will also flow downward. So in the ground story column, the P will be 3 times. Okay. So the P delta effect, you will calculate accordingly. So your story V versus delta curve will change. So first you will, in question number 3, you will calculate V versus delta without P delta. Then that V delta will be modified considering P delta.
we have considered this story. Only 2 story we have calculated, or we have considered this also. 4 story we have considered this. Then the P is considered only this portion. That or we have
Same thing which we have done in case of Q.
approximately.
Actually, on any sub-assemblage here, like, and there is a Q also here. Similarly, there will be a summation P from here, and then another P will be acting here. The summation P is from the upper story. Okay. So what we will do, like we have done here, we have considered actually we considered V plus Q over the whole story. We have considered story shear from the mid height. Actually it will come from the floor, but we have assumed those forces to be acting at mid height. Okay. So similar way we will consider this also as summation P plus Q from the top. So actually your gravity load will also increase from the floor level. The lateral force will also increase from the floor level. But assembly we are considering from mid height to mid height. Okay. So we will take the higher. So can you handle this? Now look at question number 5. Can anybody suggest me? Which question you are? 5? Can anybody tell me how to solve question number 5? There is a 15-story tall chair. So, let's assume that this force is increasing linearly. So if there is a linearly increasing force, where will the resultant force act? If this height, 15 into 3, this is 45 meters. Where will the resultant act? 2 by 3. of H, that is 30 Newton. Okay, then how much? And this total force is, let us say, BV, so this will also be BV. How much will be the moment? How you will get BV by? Okay, My divided by. How to get My? The yield moment. The cross section is given. So for the given cross section and the reinforcement, can you calculate My? So which capacity it gives? The 13920 annexure you have done in the first semester, design for shear wall. Which capacity it is given? Limit moment capacity. Okay. Ultimate with factors of safety and characteristic strength. What we have to do? We have to use expected strength and factors of safety 1. Use that, then you will get ultimate moment. And assume that the curve is like this, and My and Mu are same. Let's assume that. To simplify your calculation, otherwise you have to do moment curvature analysis, and from there, after bilateralization, you will get My and Mu. Okay. We are assuming that My and Mu are same. You know the procedure in 13920 to calculate Mu. Same procedure we will use. It may make slight error, but it doesn't make much of a difference. So Mu you will calculate. From that you will get My. From where you will get these values? From where you are going to get these values? I have given in the question. You will calculate this stiffness. How to get this stiffness? Theta y is not known. For calculating theta y only I am using K. So how to obtain this K? Using effective EI. Okay. How to get EI effective of a shear wall? Again, the table is given for cracked section stiffness in SC 41. So you will use the factor given in SC 41 as some factor C times EC into T is the thickness of the shear wall, L is the length of the shear wall, divided by 12. This C is coming from this constant for crack section stiffness. This is coming from SC 41. And keep in mind, for calculating this Mu, you have to use the expected strength, not the characteristic strength. Okay, and Fye and gamma is equal to 1. So wherever in that annexure FCK is used, you will use FCE. Okay, and expected cube strength, not the corrected strength of the structure, because those correction factors are built in in those expressions. So only FCK you will replace by this, FY you will replace by this, and wherever those factor 1.5 or 1.15 is there or 0.87 is there, you will use 1. Okay? And then AC41 gives you values of A and B. You will take these values of A and B from there.
Sir, should I consider the confining effect there while calculation?
Is there any confinement given? So life becomes simple. But even if confinement is there, okay, we are calculating MU using that expression given in the board, okay, and that does not consider confinement.
So the yellow factor is equal to CEC. EC is crack.
EC is modulus of elasticity of concrete, 5000 under root FCK. FC. In case of FCK, we will put FCK.
The boundary element is also there.
Then you have to do section analysis,
As if we
like you have done in case of a column. So you will consider the, suppose the shear wall suppose shear wall is like this. Then you will perform a section analysis. How? Same assumptions which we have done in case of beams and columns. Plane sections remaining plane. Okay. Stress strain curve of concrete and steel. Strain you will assume in concrete or steel. Okay. Then you will calculate strain at all rebar locations. And then you can calculate the stresses. Then you can calculate C. Then you can calculate T. Then C minus T equal to P. Like that.
This whole assembly will become a section.
This whole assembly,
Will become a section.
yeah, this is a section of a shear wall. Here it may appear very large, okay, but when you talk about 15-story building, then it's not that large as compared to that height. Okay, suppose this length is 3 meters, so it will look large from the point of view of a column. But when you consider 45-meter height also, then this will not appear to be very large. It is a cylinder system, and plane sections will almost remain plane. Compressive force. How to get compressive force? Because for calculating moment capacity of the shear wall, you need compressive force. So how we will get compressive force for this building? First of all, at which level we need compressive force? At what height? Okay. At the base. Okay, because yielding will occur at the base. So we need to calculate the capacity at the base. So how much will be the axial force in the shear wall at base? How do we calculate? The floor load, you can assume same 15 ton per meter square is a very good estimate of that load plus light load. So 15 kilonewton 1.5 ton or 15 kilonewton per meter square. Okay, that you can assume per meter square. Distribute in terms of tributary area to the 4 walls, identical 4 walls, square plane, so I equal force will go. Okay, so you will get force coming from one floor. How many such floors are there? 15. So multiply by 15. That will give you the axial force. So for that axial force, You will calculate this moment. Okay. So, can you complete it now? And if you can complete it, tell me when you are going to submit. Or you are not going to submit. Whether you want to do it this semester or next semester, I have no problem. But whenever you submit, on 4th we have the exam. So on 4th, at least one question will be there from this tutorial. At least one. More than one is also possible. Submission is your choice. Whenever you want. No correction. Corrections are already included in the so if you do correction here also, the correction will when you are calculating the stress inside the so can you decide the date or you want to decide the date also later? Okay, you decide and let me know. Even if you decide not to submit, I have no problem. But I am going to ask in the exam. I used to tell in the class, you are the boss. You will decide. Whatever you will decide, I will do. Okay? You want to submit? You decide. You don't want to submit? You decide. When you want to submit? You decide. But in the exam,